Okay, to start off with, I'm going to calculate the speed at the top of the first loop. The distance from the ground at the top of the first loop was 1.35 meters. Okay, and the total height of the thing was 1.87 meters. So what I'm going to do to find the I'm going to find the velocity. So I'm going to get that from the kinetic energy, which I'm going to find by subtracting the potential energy of the total maximum potential energy from the potential energy at 1.35 meters, and that's going to be the kinetic energy. So I'm going to use the formula m times g times h, which is mass times the attraction to gravity on Earth times the height. And for the first one, we've done this, and we get an answer of 0.0916. Okay, that was very bad. Then for the second one, we use the same formula again. We get an answer of do it. Of 0.066 joules. Not one. There we go. 66 joules. And this is also joules. And we subtract those two to get our kinetic energy, and that is 0.0256. So 0.0256 joules of kinetic energy now. And so the way I'm going to get velocity is I'm going to take modified version of the formula Ke equals 0.5 times mass times velocity squared, which is the square root of Ke divided by 0.5 times the mass. Whoa, that's weird. Okay. Ke times equals velocity, because we're trying to find velocity. And we know the kinetic energy and the mass. So how I'm going to do this is, no, I'm just going to solve it. So we take 0.0256 divided by, the mass is 0.005 kilograms. So that, and we get an answer of 3.2, or velocity at the top of the first loop is 3.2 meters per second. Okay, now we're going to calculate the velocity at halfway down the first descent. Halfway down, we didn't actually do it exactly halfway. It just halfway was at a weird point. So we were calculating. We measured at 0.61 meters. So yeah. So 0.61 meters off the ground. Okay. And the way you find this is the exact same as before. You find the potential energy for this, which equals 0.005 times 9.8 times 0.61. And for an answer, that is really bad. For an answer, we get 0.0299. 0.0299. You remember for the last one are joules. Okay, don't forget the unit. And you remember for the last one that our maximum potential energy was 0.0916. Okay. 0.0916. Okay, there we go. That's over. And so we subtract them like before. Same process actually. 0.0299. We get an answer 0.0617 joules of kinetic energy. We use the same formula as before again, the square root of Ke divided by 0.5 times the mass. And I'm not going to write out the digits, I'm just going to solve it for you guys. And we get 0.0167 divided by the mass. We get 4.9, about 5 meters per second, at about halfway down the first descent. Okay, now we're going to calculate the velocity at the top of the hill. The top of the hill was near the bottom. It was actually 0.37 meters off of the ground. And so we're going to calculate with the same formula, m times g times h, and get as an answer 0.37 times 9.8 times 0.005, and as our answer we get 0.018. 0.018 joules. And we subtract that from our total, which is 0.0916 minus 0.018, and that is 0.0736 joules of kinetic energy. And so we have that, so now we're going to use the same formula, the square root of kinetic energy over 0.5 times the mass equals the velocity. And we solve this out, 0.0736 divided by we get an answer of about 5.4 meters per second. About 5.4 meters per second. And that is the speed at the top of the hill.